Today we will know about how to easily calculate the hybridization and how from that very calculation we can determine the structure of different compounds and molecules. At first we have to keep in mind a formula that is H equal to half of V plus M minus C plus A. In that very formula, H stands for hybridization count. That actually will be a number. We will discuss it later. And M stands for number of monovalent atom. If any divalent, trivalent or any other atoms having more than valency of 1, then that count need not to take in that very formula. And after that, C is total positive charge in the given species or molecule, and similarly A is the total negative charge given in the species. Additionally, we have to keep it in mind that lone pair repulsion will be much more higher than those of lone pair bond pair repulsion than those of bond pair repulsion. Now, what is actually bond pair? Bond pair means two electrons forming a bond. And what is lone pair? Suppose any atom is there, that is X, and it has two electrons that are actually not bonded with any other atom or moiety. Okay, then another thing we have to uh, keep it in mind that lone pairs, if there is a lone pair or two lone pairs, that will be placed in the orbital having more p character, okay, and as well as more electronegative atom that will also occupy the orbital having more p character. And there is also a trick that if competition is set between lone pair and any electronegative atom, then lone pair will get priority. Okay, now come to the examples one by one. At first we can take CO2. Then very simply we can put the formula H equal to half of V plus M minus C plus A. Now carbon has the total valence electron equal to 4, so it is equal to half of 4 plus. Now if there is any single electron or not, that will have to be found out. There is no monovalent atom because two oxygen atoms are there, so these are divalent or bivalent, so the value of M here will be 0. Now we have to find it out that whether there is any positive charge or negative charge. No, there is no positive or negative charge, so this will be all 0, giving the value 2. Now tricks is that if 2 is there, divide it into 1 plus 1. If the result comes 3, then you can split it, suppose 3, then split it in 1 plus 1 plus 1 and so on. Now first one value stands for S, another for P, in that case is P, another P, that means P2. If your that H value comes 4, then it can be sp3. And similarly, maximum value of p can be 3. And after that, if 5 comes, then sp3d. For 6, that will be sp3d2. And for 7, sp3d3. Okay, now we have to know that if any compound hybridization become sp, then its structure will be linear. So we know that carbon forms double bond, so that is linear structure. In that case, central atom is carbon, so it suffers hybridization of sp, not sp2. It is, that will be sp. And after that, and that will be 180 degree, the bond angle. Okay, now come to the next example. Here the central atom is Be, so H equal to half. Number of valence electron is 2 for beryllium, and 2 monovalent atoms are there, that is chlorine. So we put 2 in case of M, and no positive and negative charge, so that will be half into 4 minus 0 plus 0, that also gives 2. So from the above example, that 2 value gives the hybridization of sp, that is, that will be linear, and the structure will be like that. In between angle will be 180 degree. Okay, now we come to the next example. Here that is Bf3, so put the formula H equal to half, and the value of V will be 3, because there are total 3 valence electrons in case of boron, and total number of monovalent atoms are 3. No positive charge, no negative charge, giving the value of 3. So 3 is sp2. Okay, sp2 gives the structure named as trigonal planar. How it looks like? It is actually in plane structure, and in between angles are 120 degrees. Okay, next we come to the next example, that is CH4. So in that case, central atom is carbon, so put the formula H equal to half of number of valence electron of carbon, that is equal to 4. So total number of monovalent atoms is 4, cause hydrogen is monovalent. No plus charge, no minus charge, giving the value of 4. Okay, so 4 gives you the hybridization is equal to sp3, 1 for s, and for 3p you can take 1 1 1, giving you total 4. Okay. Now the structure for sp3 hybridization will be tetrahedral or tetrahedral, no problem. In case of E, you can use Y also. How it looks like: C is central atom, hydrogen, 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 and hydrogen. In between angles are 109 degree 28 minute. Okay. Next, similar hybridization will be observed in case of ammonia, but there is a tricks, cause nitrogen in that case will have a lone pair. Okay, can it be determined by that very formula? Yes, just put the formula: H equal to half number of valence electron in case of nitrogen is 5, number of monovalent atoms is equal to 3, that is hydrogen, no plus charge, no minus charge, giving you total 4. So that is the tricks, because it also gives you sp3 hybridization. Sp3 means we know that tetrahedral, so 3 hydrogen atoms are there, but we know that in case of tetrahedral structure there are total 4 positions, and in those 4 positions 3 positions are occupied by hydrogens, so one position is remaining vacant, that will be occupied by a lone pair. Okay, that very structure is known as pyramidal, so that will not at all termed as tetrahedral structure, that is pyramidal. Good. After that we can take the example of water similarly. What is the valence shell of oxygen? What is the number of electrons in the valence shell of oxygen? That will be 6. 2 monovalent atoms are there, so 2, no plus charge, no minus charge. Okay, giving you total 4, that is also sp3, and it is expected that that will give tetrahedral structure. Okay, keep the oxygen atom being central atom in the center position, so there must have 4 positions as it is suffering sp3 hybridization. So 2 hydrogens are given or supplied, so there are 2 positions that are not at all occupied by any other supplied ligand. So these 2 atoms, sorry, positions will be occupied by 2 lone pairs, that is called Mickey Mouse structure. Or it is called V shaped, that looks like V. Okay, it is called V shaped structure. Next, come to PCl5. In that case, just count H equal to half the number of valence electron of P, that is 5, number of monovalent atom is 5, and no negative charge, no positive charge, giving you 5. So it is sp3d. It is called T, that gives TBP structure. What is the full form of TBP? Trigonal bipyramidal structure. Now, how it looks like, just you can compare it with BF3, not only, not the whole structure, but partially. Look at the structure, that looks like trigonal planar, isn't it? But with these three chlorine atoms, two chlorine atoms are located there. You can take it as above the plane Cl, and another is below the plane Cl. Okay, so in that case, the two these two chlorines are in axial position, and those three chlorines are in equatorial position. Come to the next example, that is SF6. Put the formula H equal to half valence electrons of sulfur is 6, number of monovalent atom, that is chlorine, is 6, no cation, no anion. Okay, so giving you the number 6, that will give sp3d2, that forms the structure octahedral. It is basically square planar along with above and below. So sulfur is in central position, 4 fluorine atoms are in 4 corners, 1 fluorine is above and 1 fluorine is below. That very structure is known as octahedral structure. And last, IF7, just put the formula H equal to half number of valence electrons in case of iodine is 7, and total number of monovalent atoms, that is in that very given example is fluorine, is equal to 7, no plus charge, no minus charge, giving you 7, that is sp3d3. That very structure is known as PBP. Full form is pentagonal by bipyramidal. So how it looks like, that is nothing but a pentagon above and below. So here is I put fluorine atoms 1, 2, 3, 4 and 5. These are planar, and below the plane 1f and above the plane 1f. So it is giving me I 8 7. It is essentially an interhalogen compound. So there are so many critical examples that can be explained with the help of that similar formation or formula I will bring to you in next session. Thank you.